Hi, we are from Group 6. Let us talk about DC machines that work on the principles of electromagnetism and electromagnetic induction. There are two types of DC machines, which are the DC motor and DC generator. Let's first look at the DC motors.
Assalamualaikum, we are from Group 6 and we're going to demonstrate how motor works. We're going to using battery, copper wire, magnet and screw. And when the circuit is complete, electricity flows through the wire creating a magnetic field. This interacts with the magnet and causes the magnet to spin, and that's how a basic motor works.
When the simple motor circuit is complete, the magnet spins. This is because a DC motor converts electrical into mechanical energy. A DC motor uses the concept of electromagnetism, which is related to electricity and magnetism. Electromagnetism is a process where a magnetic field is created by introducing current in the conductor. But, how can this electromagnetism generate motions? Before explaining it further, let us look at the basic components in a DC motor. A DC motor is made up of two magnets to form a strong magnetic field. A shaft is placed between the magnets. Then, a rotor is attached to the shaft. There will be coils wrapping around the rotor. The coils are then connected by a commutator. The brush and arm will provide power to the commutator. Lastly, the DC motor is connected to a power supply. How does a DC motor work? First of all, turn on the power supply to the DC motor. The brushes only allow a section of the commutator to be connected at a time. Now, look carefully at the coils to determine the direction of the current on the left and right. The rotor is a conductor with magnetic domains that are initially not aligned. When current flows through the coil that is wound around the rotor segment, the magnetic domains will align, forming a north and south pole just like a magnet. It is now known as an electromagnet. The electromagnet will constantly attract and repel with the permanent magnet in the DC motor, and this is how the rotor spins. An easy way to determine the direction of the forces that push and pull the electromagnet causing it to spin is by using Fleming's left-hand rule. By using Fleming's left-hand rule, we know that there will be an upward force on the left and a downward force on the right. This makes the rotor spins in clockwise direction. Now, let's try to light up a LED using a DC motor. Try to rotate the fan blade or the shaft directly and see if the LED will light up. Surprisingly, you can get different results. This is because a DC motor cannot work as a generator. However, some of the DC motors in the market can work as a generator as well. So, talking about generators, how can a generator light up the LED? This is because a generator is the reverse of a motor. It converts mechanical energy into electrical energy. When we rotate the fan blade, the shaft rotates followed by the rotor. As the rotor spins, it cuts the magnetic field line and generates an induced current. And this is what's called as electromagnetic induction. Electromagnetic induction occurs when there is a relative movement between a conductor and a magnetic field, causing the magnetic field lines through the conductor to change. This change in magnetic flux induces a voltage in the conductor. The mechanical energy is converted to electrical energy. In conclusion, we have two types of DC machines, which are the DC motor and generators that work reversely using the principle of electromagnetism and electromagnetic induction.